Hi there. We looked today in class at a variety of different integration problems and started practicing identifying the patterns we could use to help us see which integration rule will allow us to solve the problem. For example, if you have a problem and you can rewrite it in this form, a singular variable to an exponent, as long as that exponent isn't -1, then you know you're going to use the power rule to solve the problem. Or if you can rewrite the problem in this form, 1 over a singular variable, which would be a singular variable with an exponent of -1, then we know we're going to use the log rule for integration. This blue paper that I'm looking at here is the one I passed out back in Unit 4. It's also the very front of your calculus book, and I would recommend that if you still have this blue paper to pull it out, lay it alongside your homework assignment. That way you have something to reference for each problem, especially here at the beginning of Unit 5 where we're just getting used to the patterns and figuring out what we are looking for, what's going to help us give that cue about which integration rule to use. So I have 3 types of problems here. The first one is the integral of x minus 12x squared over x cubed dx. With all of these integral problems, we're going to start with the question, can we rewrite it in that first integration rule form? An exponent, a singular exponent to a variable. Because if I can, that's power rule, fantastic. We add 1 to the exponent, divide by the new exponent, and we're good to go. Okay, so I notice with this problem that I have x cubed in the denominator, a singular term, which means that I could rewrite that as x minus 12x squared, quantity, times x to the -3. And now that I have a quantity without an exponent, I know I can distribute that x to the -3 into both terms. And so this would become x to the -2 minus 12x to the -1. Okay, so now that we have this x to the -2, that fits that power rule. Singular variable to an exponent, as long as the exponent isn't -1. And so I know I can use power rule for that integral term. I know I can use power rule to take the integral of that term. Okay, so I'm going to go ahead and add 1 to the exponent and divide by the new exponent. Unfortunately, this 12x to the -1 doesn't meet our power rule criteria because there's a -1 in the exponent. So I'm going to go ahead and rewrite that for now. It's 12x to the -1 dx. If for some reason you missed that, I'm going to go ahead and show you what you would see. So if you did try to use power rule here, with the 12x to the -1, well, you'd add 1 to the exponent and get x to the 0, and you divide by that new exponent, and that's an issue, okay, because we can't divide by 0. That's going to be your signal that if you get that divided by 0, chances are you missed a log rule. Okay, so you're going to go back to your original term, this 12x to the -1, you're going to see, can I rewrite it so it looks like my second rule here? 1 over a singular variable. Because if you can rewrite it as 1 over a singular variable, then you're going to take the natural log absolute value of u. Okay. Well, sure enough, when I look at this problem, I see that I can rewrite that x to the -1 as 1 over x. And now it matches my log rule for integration. I'm going to go ahead and rewrite this as -1 over x minus 12, and the integral of 1 over a singular variable is the natural log of the absolute value of that variable plus c. And that's my answer. Okay, so for our second problem here, again, we're going to start with that first question. Can I rewrite it in the form of a power rule, right? A singular variable to an exponent. And if you tried to at first, we would rewrite this as 8 minus x squared to the -1/2. Unfortunately, because our quantity has an exponent, I'm not going to be able to distribute into it. Okay, so that's going to be my signal that initially this isn't a power rule. Okay. So then the next question is, can I rewrite it in a u du form? So let's go ahead and try that. If I make my u 8 minus x squared. Well, my hope is then that my du will be able to substitute out this x dx. Okay, so du, derivative of 8 minus x squared, is negative 2x dx. And sure enough, I see the x dx right here. So all I have to do is reconcile this negative 2, and I'm going to do that by dividing that negative 2 over to the other side. So now I have all the components to substitute my u du. The x dx is going to be equal to negative 1/2 du. And the square root 8 minus x squared is going to become square root u. And now I'm back to the beginning. Can I use power rule? Singular variable to an exponent. And sure enough, when I rewrite this as negative 1/2 u to the negative 1/2, I have power rule. So I'm going to add 1 to the exponent and divide by the new exponent. So we have negative 1/2, add 1, divide by the new exponent. And from here on out, it's going to be a process of simplifying where we can, and then substituting back in our x values in for our u. Okay. So I'm going to go ahead and rewrite this negative 1/2. Divided by 1/2 is the same thing as multiplying by the reciprocal, so we're going to go ahead and times by 2. And then I'm going to substitute back in my 8 minus x squared into this u. And then last step, negative 1/2 times 2, they cancel each other out, so I'm left with negative 8 minus x squared to the 1/2 plus c, or negative square root 8 minus x squared plus c. And so that's my answer. Okay, so our final problem here is the integral of 15x squared minus 2x plus 3 over 3x minus 1 dx. Again, first question, can I rewrite it as a power rule? Unfortunately, in this case, I can't. If I did make this quantity 3x minus 1 to the negative 1/2, you'd have an exponent attached to that quantity. You wouldn't be able to expand it, distribute, anything like that. And so then you might try your u du's, and no matter which u you make it, u equals 15x squared minus 2x plus 3, you aren't going to be able to make your du. If you make your u 3x minus 1, again, you won't be able to make your du. And so then that leaves us with our final technique, which we learned today, which is our long division. Okay. That way we can rewrite our integrand. So if I go ahead and set this up, my numerator, 15x squared minus 2x plus 3, denominator, 3x minus 1. So I'm going to ask myself, how many times does 3x go into 15x squared? Well, that goes in 5x times. 5x times 3x is 15x squared. 5x times negative 1 is negative 5x. And then we're going to channel our inner fourth grader and make sure we change those signs. 15x squared minus 15x squared is 0. And negative 2x plus 5x is 3x. And then this 3, there's nothing to combine it with, so I'm just going to bring it down. Okay, so then we ask, how many times does 3x go into 3x? Well, that goes in 1 time. 1 times 3x is 3x. 1 times negative 1 is negative 1. And again, channel our inner fourth grader, change both signs. 3x minus 3x is 0, and 3 plus 1 is 4. And so I'm left with a remainder of 4 over 3x minus 1. Long division doesn't take the integral. Long division just rewrites the problem. And so now we have the integral of 5x plus 1 plus 4 over 3x minus 1 dx. And so we're back to that first question. Can I rewrite this as a power rule? Can I use power rule? Singular variable to an exponent. And for these first two terms, I can. Okay, so we're going to add 1 to that exponent, so this becomes x squared, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Integral of 1 is x. Unfortunately, with this one, we aren't going to be able to do that, so this one is going to be my u to u substitution. So for now, I'll go ahead and rewrite this as 4 over 3x minus 1 dx. So if my u is 3x minus 1, then my du is going to be 3dx. Which isn't quite like 4dx, but I can make it like 4dx by dividing the 3 over and then multiplying both sides by 4. So now it matches my 4dx. So I'm going to go ahead and do my u du substitution. I'm going to bring down this 5x squared over 2 and this plus x. The 4dx is going to become 4/3 du. The 3x minus 1 is going to become u. And again, if you have that blue paper out alongside your homework assignment, which again I recommend, you're going to look to see which pattern does this problem fit. Well, right here, our second rule, log rule for integration, integral of 1 over u du is the natural log of the absolute value of u plus c. I see integral of 1 over u du, so I know I'm going to use that natural log rule. So we have 5x squared over 2 plus x plus 4/3, and the integral of 1 over u du is equal to the natural log of the absolute value of u plus c. So our last step is just to substitute back in my u, 3x minus 1 into u. And so we have 5x squared over 2 plus x plus 4/3 natural log of the absolute value of 3x minus 1 plus c. And that's my answer.